Hi, I'm David. I want to show you how to do the homework for the linear equations on Delta Math this weekend. This is basically a review of the slope-intercept equation. The slope-intercept equation you might remember as mx plus b. M is the slope, how we change. This has been our rule when we've been looking at sequences. The arithmetic sequences, the rule has basically been there. And b is our y-intercept. That is where the x value is 0, or in a lot of ways, our starting point for many of our sequences. So there's hopefully a direct connection to how we've been doing linear equations with arithmetic sequences. So let's practice some of the basics. You might have obviously done this in the past or never. Hopefully we'll either refresh up your skills or you'll learn some stuff real quick. So here we go. Hang on. Forgive me, my daughter was bouncing a basketball there. So, okay, here we go. We need to find the slope and we need to find the y-intercept. As I said, when x is 0, you have the y value will be the intercept. If I am graphing, and it's a good idea to keep an eye on the graph here, this has a starting dot at 0, -1. And it's growing by a slope. This is again like the sequences. So how is it growing? Well, this one seems to be going up 5, up 5, up 5. And just double check, are the x's going by each term or each x value? So the rise over run, the change of x, or excuse me, the change of y over the change of x is the best way to think about your slope. So again, this is like our rule. This went up 5 plus 5 and over 1 x value. So now we'll type in the answer. The slope is 5 over 1. Well, that's just 5 x. Remember, the x value comes after the slope as we saw above. Then we have the y-intercept, and we saw that was -1. This equation would go up 5. If you were down at -1, that would take you up to 4 and over 1, and that's how this line would look. This line would look just like that. Let's try another problem. Just real quick and see how it changes. We'll speed up the process a bit here. I have a y-intercept of 4. So I already know the equation's plus 4. It looks like the slope is going up 4 over 1. I'm looking at the rise over run. So the rule seems to be increasing by 4, double check, yep, and changing by 1 in the x. So then we're going to put 4 for the slope, x, and hit submit. Remember that you get 2 attempts for each one of these problems. 2 attempts for each one of these problems. The next problems we're going to do are we're going to try to extract from the graph the key information, basically the linear equation. We're still going to use mx plus b. We're still going to use slope-intercept, y equals mx plus b, to keep it consistent. And again, we're looking for pretty much an arithmetic situation where we analyze the rule and find what the slope is. We analyze the rule and find where the slope is. It's just a little bit harder here because we're doing this off a graph. Key things to look at when we're doing this problem. We're talking about filling up the gas and embarking on a road trip. But here's the key sentence. G represents the number of gallons of gasoline. That's your y coordinate. It says it on the left. And that's how much gas is remaining, after t hours, So hours is the numbers on the bottom. So that's key information here. Let's take a look. We're going to try to put in the equation, G. It's kind of like y equal in this case. We're going to talk about the slope here in this problem, and then we're going to talk about how the slope connects to the numbers of the number of gallons of gasoline that's remaining. So first, let's do what we've done before in the past. Let's analyze how far the rule is. The rule seems to be coming down by 5 and over by, I'm looking at the x coordinate right there, okay, and I'm watching the y coordinates. So there's only one dot I can trust right there, and that dot is technically at 4,10, but looking at the slope, it looks like the rule is we're coming down 5 gallons of gasoline for every 4 hours on this trip. That is how we're using rise over run again. So coming down 5 over 4, down 5 over 4. So how does that equation look? Well, we can just type it in, -5 x, because we found the slope. And we're going to use the y-intercept. Let's observe the y-intercept. It starts at 15 gallons. The next part is to reveal the slope of the equation, which we already said, -5/4. So we'll type that in. And then we're going to say what that means. Let me clear that screen. It got a little cluttered. So what does that mean when we come down 5 over 4, -5/4? Well, that is the number of gallons of gas used per whatever the x-axis is. So looking at the x-axis, it looks to be number of hours. So we're going to go per hour on that one. A little bit tricky here, but I have a feeling you'll be able to do it. Last one I just want to show you is basic graphs. So this is how to use the technology with Delta Math here. We have to click and drag a line. So let's use the fact that we see it's got a y-intercept of -3. And I always tell students to put the negative on the numerator, So read that -1/3. I really recommend reading that -1/3 as a down 1 over 3. This is the equivalent of a fraction that's -1/3. But in high school math, we tend to put the negative in the numerator more than anything else. It makes more sense. All right, let's see if I can do this. I'm going to start at the y-intercept at -3, and I'm going to click. I'm going to click once, let go, and now, oh, it's making a line. Okay, so now I'm just going to kind of go down 1, 2, 3, and over 1 and mine the slope, and then click again, and now I have a line. Let's try another one. That was kind of fun. Don't forget to hit submit answers. Don't forget you get 2 chances. On each problem, you do have a limit to the problems you get. But at the same time, I want to challenge you to try to get them done. I don't want you to go forever. That's technically why. All right, you ready? Slope is starts at 2, so I'm going to click on the y-intercept to 2, and now it's making a line. I'm going to read that slope as down 2 over 3 and click. And there you go. And that's how you graph a line on the computer. I'm David. I hope this is going to help you get through the linear equation homework.